everyone. Oh, you can hear me well. I can hear myself very well. I hope everyone is in. We have still a group. So I will just wait a bit for you guys to sit down, and then we will start. So let's start with a very, very simple question. I'm really interested in how many of you are familiar with machine learning? Wow, that's nice. How about recommendation systems? Okay, not so many, but this is a very nice audience. So what we will be talking about now is recommendation-based product ranking. This means that we use recommendation systems to rank items on a domain. And as background, we can think about all of the information that is currently available. So when we want to watch a movie, we go to Netflix, and there are thousands of movies available. We want to listen to a song, we can find, again, tens of thousands of songs that we might be interested in. We want to buy groceries, and there are 100 types of milk products that we can choose from. So as a customer, it is very difficult to pick the right one. And when you are only offered a limited selection, let's say maximum 7 or 10 products, as a person, we are very capable of choosing what we like. If we are displayed 100 products, we will look through them. We will try to pick the right one. And 1 hour later, we're still there trying to decide what milk to buy or what movie to watch. How many of you have spent evenings trying to find the perfect movie to watch and ended up, yes, I see you, ended up just watching some trailers, and then it's like 12 o'clock, no movie watch, and yeah. So that is why we want to have recommendation systems, and we want to have our selection, given a query, sorted by the likelihood of a product to be chosen. And the biggest problem is that we cannot display all of the options. Displaying 100 movies will only result in exactly the scenario that I described. We spend the nights watching trailers. So the solution is to have everything personalized, to limit the options for users to something that is very relevant for them, such that, in the end, they end up with a solution in a short time. Because actually, there are so many platforms offering exactly the same thing. So if I have to choose between the one which enables me to watch a movie and the one which results in a wasted night, guess what I'm going to choose as a customer? And then what we switch from is this idea of selling products just for the sake of having them bought, and we switch to putting the customer first. And then we try to offer the customer exactly what he would be interested in. And actually, this results in some very nice statistics. So basically, at Netflix, 2 out of 3 movies watched are recommended. We don't talk about the ones for which you just watch the trailers. At Amazon, 35% of the sales come from recommendations. So basically, products recommended when you look at whatever you're looking. At Google, news recommendation increased click-through rate by 38%. So this is very important. And not only in regards of results, but also in regards of customer loyalty. Customers are more likely to stay if they are offered the right content. And then the rate of churn is decreased. So, switching to recommendation systems, how do they actually work? The idea is very simple. Most times, you buy a product, you look at a product, and you rate it. Most times, it's 1 to 5 stars, like, dislike, only like. However, in the world of big data and unlimited databases, we have a lot more feedback that we can take into consideration. Actually, statistics show that only 10% of the customers provide feedback. However, they do provide implicit feedback. Implicit feedback might mean that they write reviews, analyzing text, something like we see there, really liked product, disliked product. It's more difficult than it seems, but that would be a different talk on NLP and sentiment analysis. We can, of course, consider purchasing, things that customers put in their basket, things that customers look at. Watching the trailer of a movie shows interest. Putting an object in the basket, saving for later, adding to wish list, those are also displaying user interest in the product. And this is information that can be used later on in an algorithm. There are several classical approaches for recommendation systems, and every one of you who has approached the problem has heard about this. And actually, all of the biggest companies are using them. I think they all published articles, they all analyzed, compared all of those algorithms, and they all decided on something, according to whatever their needs were. One of the most used algorithm for a recommendation system is collaborative filtering. This means that you take into consideration the past purchases. So basically, user 1 bought 2 of item 1, 1 of item n. User 2 bought 1 item 1, 5 item 10, or this can also be the rating system. And we try to see that which are the items that one user has bought, another user has not bought, but the similarity is very high. So basically, if user 1 buys exactly the same products as user 2, and another one, then we are likely to recommend the new item to the other user. This approach actually works very well. It's used in Facebook, Netflix, Google. They all use it. It's actually one of the based approaches. However, one of the big problems is that it uses a lot of memory. So basically, computing the score for every product that a customer might buy takes a lot of time, especially if you have 1 million customers and 1 million products. Another issue with this approach is that if you don't have any history, if you don't know that user 1 bought or liked several items, you are unlikely to recommend anything because there's no input. Content-based recommendations, they are related to similarities. So basically comparing users or items. There are multiple similarity distances that you can compute. One of my favorite is cosine, but of course you can use Jacquard or Jarrow-Finkler or wherever you guys want. The problem with this approach is exactly the same. So basically, if no user has bought any item, then of course they're all the same. So we would want to recommend no item to all of them. It's not an option. A more, let's say, rule-based reasoning is to use demographics in order to recommend products. This has been used a lot in the past when there were no algorithms available. So basically, we can say, OK, so we're here in Spain, so we recommend to all of the people to buy convertibles. However, if you like four-wheel drives, no problem, you get a convertible. The problem with demographic approaches is that we are not that similar within the same area. And this is something that such approaches do not take into consideration. Another very used approach is the knowledge-based one, where we have some knowledge about the users of a product. So for example, when a product is created, we might consider a target user group, and we then can recommend this product to the target user group. This works well, for example, if we don't want to recommend alcohol to minors. So if you take two users into consideration, 6 months apart from each other, but one of them is minor, the other one is an adult, if they're 99% similar, you are very likely to recommend alcohol to the minor, which can end up with a lot of problems. And The last approach would be the utility-based, where you are trying to optimize a KPI. You want to increase sales for a specific product, or you want to increase views for some specific products, and then you apply this into the logic of recommendations. The problem with such approach is that it's not customer-centric. So you don't take customer input into consideration, you just take whatever KPI you want to optimize. The problems with all of those approaches is that none of them is best. So it's very difficult to choose for a specific situation the best algorithm. Usually what happens is that different approaches, they just create similar results. However, for some users, one approach works, for another user, the other approach works. And the solution in such a case is to build a hybrid system. This means that we take several of those approaches and we combine them in some way. There are already known ways of combining those methods. So you can either run them in parallel and use a voting system on top. So basically, algorithm 1 recommends item 1, algorithm 2 recommends item 1, algorithm 3 recommends item 2, so you recommend item 1 first, item 2 second. That would be a very simple example. You can use a mathematical formula, so basically some type of mean, weighted mean, or sum in order to find which is the best algorithm or best result. And many, many times, those types of approaches, like the hybrid systems, they work a lot better than standalone models, because they take advantage of all of the advantages of the other models. But we can go deep as well. And having several input layers for the users, the user preferences, this means what they like, user features, something like demographics or information about where they live, where they study, the topics of interest, together with item features, so different classifications of items, pre-selected, as well as the actual items. So combining those together into a neural network can result in a very good approach. And very often it performs a lot better than a similar approach that we have seen before. But what are the problems here? So I mentioned during my talk a couple of them. So one of the things that you need to think at the beginning when you want to build a recommendation system is, do we buy this product repeatedly or only once? So if I want to think about my groceries and I buy a brand of milk once, I probably will buy exactly the same if I like it. But if I buy an iPhone today, and the website recommends me to buy an iPhone tomorrow, I will be like, why? Exactly. Not to mention cars. We don't buy cars every day. Very often, the perfect item would be too expensive. So those algorithms, they do not know, unless told, which is the perfect price for a customer. So the probability for a user to buy a product, it also depends on the price the product has. Given that it's sunny outside and I like to sail, maybe I would be recommended to buy a yacht, but I can't. That's just bad user experience. It also happens that our preferences change in time. We can all think about the time when we were students and we didn't have a lot of money. We had different types of activities, and we were buying a lot. Well, I myself, as a student, I was buying a lot of, let's say, cheap products. While after I started to earn money, I started to think about the environment. And I'm no longer buying all of those plastic products. Now I'm trying to buy something that has a positive impact on the environment. And this costs money. Our preferences also change seasonally. So basically, if you think about car rental, I'm always renting convertibles in summer because it's nice and warm. But I would never rent a convertible in winter. I would probably prefer a four-wheel drive. And recommending me a convertible just because I rented 5 convertibles in the past month, it's not a good option. I would not look again. And of course, our preferences change according to the environment. I listen to different music at home, and I listen to different music at the gym, and of course, I listen to different music at work. So if we think about all of those problems, what can we add extra? And this is called a context-based recommendation. So basically, it's not only the user and items that are important, it's also the context. In which context does this user buy this item? And there are multiple types of context. There's time and season, exactly what I told you about the vehicles. There's the location, example, gym versus work. The occasion, the company. For example, the movies that we watch with kids are different than the movies that we watch with our friends. Discounts are very important because some people might buy products only if they're on discount. Or if we think about price and price elasticity, basically, we all have a probability to buy a product given a price. So if it's 100 euros, I buy it. If it's 1,000 euros, I don't even look at it. So there's no way that we are displayed this information if the probability to buy it is close to 0. History is important. If there's a query, like we want to search for something, the information within the query is very important, because if we display the wrong products, the user will not buy. So how do we choose the right context? There are several known approaches in the world. One of them is performing a quantitative research. Has any of you heard of this? Not really. So this is when you create a survey and you ask customers, so which are the reasons why you choose to buy this product, basically. And for example, maybe time and location are not relevant if you want to buy milk. The problem with qualitative research is that the data is limited. You don't have a lot of users who are interested in answering those questions. So then you can complete it with a quantitative research. This is exactly what we call data analysis. So we try to see correlations between different features of context and the information of purchase, or exactly what we want to compute. Of course, the more context features that you add, the data becomes more sparse. Think about a user buying an item once in spring. If we want to add time as a context or season, you have absolutely no information about summer, winter, and autumn. However, there is also the option to select basically from the data the best features, like performing PCA, LDA, rating them, of course, surveys with the limited information. There is also an option to combine the context within your data such that you reduce dimensionality. And an example would be to create pairs of users and context, or items and context, and as long as you maximize the, or actually minimize the sparsity. So you choose basically the context which is mostly filled, and combine it with either the users or the items, and then apply the previous methods that you have seen. Of course, if you don't want to do that, you can always add another layer for your neural network, which contains the context. The problem is that due to sparsity, it's very possible that the accuracy of such a network would not be very good. So if we go back to context-based recommendations, most of the problems rely into the sparsity of data. With thousands or hundreds of thousands of users and thousands of products, it's very difficult to have enough data which reflects different purchases, especially within the context that you are trying to achieve. And another problem is that our choices, as we saw, they change in time. So basically, it is very possible that you need to dump some data after some time, as it is no longer used. One thing that I really like in regards of user behavior changes in time is representing user behavior as linear or polynomial regression, such that you have this data as an input, and then the change in user behavior can be used as a whole, basically. Another big problem with those methods, given that we take into consideration purchases or voting, is the lack of data. What if we want to launch an online shop and we have basically no information about purchases? How do we choose the right recommendations? And one of them we have saw before is the knowledge-based recommendations. However, one of my favorites is, how many of you know about reinforcement learning? Okay. So long story short, it's a system which simulates the world, and you have an agent which acts like a shop assistant, basically. And the shop assistant would propose basically a list of items. At the beginning, they would be random. However, as he proposes different options to users, he learns that if the user buys or if the user looks at those items, then it's a good thing. And this agent would have a behavior which is optimized based on a reward function. And we decide to reward this agent as we want. So basically, this agent would learn in time by trying different proposals for the customers, which are the ones that work and which are the ones that don't. OK, so if we want to have a recommendation system, what shall we think about? And what I want you to remember after this talk is basically what to challenge when you want to have a recommendation system in production. Whether you're developers or POs, it's actually very important to know whether you need it or not. So then the first question is why? Some time ago, I think 3 or 4 years ago, one of my customers asked me, Iulia, we want to create this recommendation system where we recommend our users product A or product B after they install something. And what's the problem here? It's like 2 products. Why not show them both? There's no way and there's no reason to recommend one of 2 options. The purpose of recommendation system is to recommend, I don't know, 5 out of 2,000, not 1 out of 2. 1 out of 2 is not of interest. Why? Because those algorithms, they are not very optimal. And more than that, they are also very prone to overfitting. So if you only have 2 options, dump them both. It's totally fine. Another thing that you might want to consider is whether you are, why do you want to have a recommendation system? I mean, do you want to sell a product? So if, for example, out of the 2 products, you actually wanted to only sell 1, then you don't need a recommendation for that. Recommendations are meant to reflect customer decisions. The second question that you need to ask, and then of course we don't think about algorithms yet, is how to evaluate. Think again about the milk versus iPhone. Or let's not even take the iPhone. Let's take a boat. I probably buy a boat once in a lifetime. So I need a good recommendation for that. If I buy milk, I probably buy that every week. So recommending exactly the same product that I bought, safe choice. Therefore, it's very important to know what exactly you want this recommendation system to obtain. What do you want to achieve? Is it just selling something? Is it clicks? Do you want to increase clicks? Do you want to increase views? Do you want to increase purchases? There are many things that you might want to use this for. I mean, most times it's purchases, but also views and clicks, they're very important because they allow the customers to know exactly what products we're offering. Still not at the algorithms. Another important thing is to know exactly how to represent your data. And now we think again about user item models or user item context models. Adding the context might result in a better quality or a better recommendation. However, it results also in a lot more work and a lot of time spent into feature selection and data analysis, because the problem is a lot more difficult. It's another dimension. And at the end of the day, does it make sense to add context if your recommendations increase only by a factor of 0.01? That's also something that you need to decide. So in regards of context-free versus context-based, it's exactly what I said before. Context is very powerful if you use it right. If you don't use it right, if you add the wrong context, of course, you can end up with a lot of problems that it might be very difficult to resolve. So it might be a good idea to think about starting context-free and increase the data quality with the context. And one of the most important problems that you can have while building a recommendation system is how to handle cold start. No data means that we can't multiply any matrices, we can't compute similarities, and if you put it in a neural network, it will result in nothing. So basically, all of the approaches that I presented have no impact if you have no data. And it's not only having no data, it's also having little data. 100 purchases would probably not bring a lot of information, depending on how many users and how many items you have. So many, many times, just starting with a random selection might be a lot better. And now we're at the algorithm side. And what I want to say is that there is no right choice, whatever problem you have. So basically, it's impossible, or not yet possible, to have an algorithm which actually resolves all of your issues. So that is why you need to play around and to try them on, to understand why one algorithm works and why it doesn't. And even when you look at the similarity models, it's not only, OK, so we apply cosine and it doesn't work. No, it depends on the data that you have and what kind of similarity you want to compute, because the mathematical distance between two users or two items can be interpreted different. And many times it can happen that based on the formula that you use, you can result with a good algorithm or a bad algorithm. Going flat or going deep, also very important. If you don't have knowledge of neural networks, then maybe you don't want to go deep into recommendation systems. Sometimes it works. I have seen many problems which have been solved by neural networks just because people put data in and the right result was out. However, debugging, it's a pain. So thank you very much. I think we have now 5 minutes for questions. Yes. Oh, OK. We wait a bit.
Hi, thanks for the speech. Do you think it is usual for companies to tweak or modify the algorithms in order to promote a certain product disguised as a recommendation?
Actually, it happens very often. I mean, even PageRank that Google uses is also a recommendation-based approach. And if you think about when you Google something, you have all of those, I don't know how many there are, 5 or 6 ads on top. So companies do that, and companies do that very often. If the company that you work for or the one that you're consulting for, if they want to do this, it's very important that you also perform an A/B test, because the main problem with giving those irrelevant recommendations is that customers tend to leave after some time. Think about how many times you close ads, or how many times you just stop using a product because it just recommends random things. So that's definitely a problem. However, what Google does at this point is that, so basically they have a huge amount of ads available. And then when they select the ads, they also apply a recommendation on top of the ads. So basically they show the ads which are most relevant. But that would assume that the products that you want to, or the company wants to recommend, would also be slightly relevant for the user. Do you have more questions? Have one there and one in the back.
Hi.
Hello.
Thank you for your speech again. One question regarding recommendation systems and their ability to help you explore rather than just see more of the same. Are there any techniques to achieve that? So say, for example, that I like, I don't know, say rock music.
Mm-hmm.
It's okay if the system recommends me to listen to more rock songs, but what about listening to blues or jazz, for example?
If you think about the idea between the similarity models, so basically what they consider is that if, for example, you like rock, and the guy next to you, he also likes rock, but he likes classical music as well, and your preferences are very similar, then what happens is that when you compute the value for the empty, so basically for the classical music items, you will also have a high score because you are similar to the other user. So this allows you to explore a lot.
Hello. I have a question regarding if you have any advice where in a situation where the items can be sold only once, so you cannot recommend the same item to several people. I mean, you can, but the item exists only once.
Can you please repeat that?
So instead of, for example, eBay, where an item can be sold to 10 or 20 people because there are many copies, a context where the item is only one, for example, in a marketplace for second-hand items.
So basically, this is not necessarily a recommendation system problem, because what you want to display this item to all of the users who might be interested in it. But once somebody buys it, it's off the list. So in the case where you have all of those items which come and go, I think that would be what you actually meant. So you have a lot of items, like hundreds of thousands of items, and they're only available once, and then you can't have history for this item. Then you take item features into consideration. So when you, instead of inserting a list of item IDs into the model, you insert a list of item features. So let's say I prefer the second-hand option because it's something that can be easily related to the previous one. So let's say we're selling second-hand cars. And basically, you have the car brand, you have Mercedes, you have BMW, you have Dacia, you have the car size, the number of doors, the power, and instead of inserting something like item ID, you basically insert the vector with all of the features. This can also help you if the item does not appear only once. So basically, if you don't have enough data for all of the items available, then you just use the features, and then you would recommend something that's slightly similar.
Hi. I've got a question related to the second question we had today. It's regarding this sort of famous filter bubbles you can create if you expose somebody to the same recommendations all the time along. do you have any way to measure those people who really find something which is not within the recommendations, and how to spot those things? Because maybe there's something you don't know you like or you need, and you're not exposed to those things because of the recommendations, but there are likelihood that you will buy those things. So do you have any techniques to measure that?
Yeah, so one of the things that I want to mention, and it's actually a very good question, is that all of the algorithms that I presented today, they would recommend something that they have seen before, just like machine learning. I mean, if you provide new data, which cannot be really explained, then the algorithm would definitely, excuse my language, suck at it. But a nice technique that you can use is to insert randomness a little bit. So let's say that you want to recommend 10 items. Like on the first page, you have 10 items. And you can, of course, recommend them by the score. So basically, most of those models, they give you a probability score. And you can have the items that you want in a decreasing order by probability. And you decide that, OK, 2 out of 10 will be just random items from the rest of the list. So basically, you just shift some in between. And what the customers would see, it's something that they actually like. So if you think about music, you have songs that maybe you have listened to, maybe songs that are coming from artists that you already know and you like. And then you have 2 more, which are slightly random, that are unrelated to whatever else you have. This would allow you to explore a little bit more. Do we have any more questions? I hope this answers, right? Yeah, OK. Do we have any more questions? OK, thank you very much.